Welcome to One Chemistry. Always try to do your best. Now let us see about 100 conversion in organic chemistry. We are seeing it as episodes. This is the episode number 55. If you didn't watch previous episodes, I encourage you to go and see. Here we solve 5 problems step by step. Stay tuned. Let us see the question number 1. Question number 1 contains fused system with benzene and a 4-member ring. 4-member ring attached with allyl system. Here heat is given. So obviously it's a pericyclic reaction. So the ring closure is matched here. So the products are suggest the way of ring closure and ring opening of 4-member ring. So the position and configuration adult one is real question, and the answer D suggests the formation of any other aromaticity also suggested. So from the question and answer you might guess it's a pericyclic reaction. The answer is A. Let us see how. It is a pericyclic reaction. The 4-member ring opened first due to its strain. So the 4-member ring opened. It's a thermal. So only 4n pi electron is involved. So the pi electron forms there. So the ring opening, 2 pi bonds are formed there. So 4n thermal conrotation. It opens the ring in cis fashion. Then the next again the reaction proceeds. Why? Because there is a chance of aromaticity. So the reaction again produced to further cyclization. So again the ring closure occurred. The new ring formed there and aromaticity also established here. Here you have to know the driving force, P and all those one. The first step driven by the strain, second step driven by aromaticity. So whenever you see the system, you have to always continue to the stability here. Same thermal goes in con first, second in dis first. So you have to understand very important thing, that is the table. If it is 4n thermal it is con. If it is 4n plus 2 thermal it is a dis rotation. Then the question number 2. The starting metal is a 5-member system with tertiary butyl group and one alkene also involved. The reagents are N-bromosuccinimide and sodium hydroxide. And next step you are using the methyl copper lithium, which is an organometallic reagent. They ask you to find the products. The products are mostly similar but they differ in the stereochemistry. So the position of OH and methyl is the real question. So from the question and answers you might understand that the bulkiness of tertiary butyls played the role and stereochemistry versus reactivity is the real question there. The answer is A. Let us see how. The starting metal contains tertiary butyl group and alkene. You are using NBS. NBS is the brominating agent, so bromination occurs. So bromine is the bulky group as well as tertiary butyl also bulky group. So bromine approached from below there. So bromination is a syn addition. Both bonds are below the ring, it's occurred. Next step we are using the base. The base is kind of SN2 reaction. It needs backside attack. So already bromine is on below. Backside attack means always it is possible by axial bond. So axial available only in the upper side. So it go above the plane. It's a very important one. It's against the normal theory because it formed near the bulky groups there. So OH go above the plane. The next thing is bromine also good leaving group. So intra SN2 kind of reaction will be there. So O attacks, bromine leaves and the epoxide formation will be there. This is possible because of bromine good leaving group and the position is perfectly trans to each other. Next step you are using methyl copper lithium, which is organometallic reagent. It supplies CH3 minus methyl anion. So what really happened is methyl ion opened the ring. Methyl ion opened the ring from below since tertiary butyl is bulky there. Here you have to learn 2 things. One is bromination is always syn addition. Syn addition means both bonds in the same plane. Then SN2 need backside attack. Hence OH comes here above the plane. Then the question number 3. The starting metal is the spiro system with 5-member and 6-member ring. 5-member ring contains methyl above and the ester below. And ketone also there in the 6-member ring. Here you are using the ethylene diol and tosyl. You are using titanium aluminum reagent. From the product you might guess what really happens to ketone is the real question. Which ketone will be reacted also real question here. So the product COMe, what happened? CO is what happened here. These all are defined by the reagent. So the whole question is about the selectivity of the reagent there. The answer is C. Let us see how. The starting middle is spiral system with methyl and ester below. Here using diol there. Diol group have peculiar property. It will protect the ketone group. So ketone is protected by diol by the 5-member ring formation. Next step, you are using the reagent of titanium and aluminum. Technically it is called Tepe's reagent. Our reaction it may called as Tepe elimination there. So what really happened is CO becomes CH2 there. So the reagent is very much important because it only attacks the carbonyl there, converts it into alkene. Then the next step you are hydrolyzing. During the hydrolysis what really happens is deproduction happen and ether become OH there. So the double bond near OH, you might guess it's a hetoenol tautomerism. So the alcohol become ketone there. So COH becomes CO there. Here you have to learn two things. One is diol group protect the ketone. Second thing is Tepe's reagent converts CO into CH2 there. Then the question number 4. The starting metal is heterocyclic system with nitrogen and oxygen, where N substitution happen it attached with the ethyl ketone and nitrogen and oxygen connected by the keto group there. One isopropyl group below the plane. Here reagents are given. Reagents are containing epoxide with tosylate group and you are using lithium HMDS. Here products are given. The products are really about how the epoxide group is attached there. And the stereochemistry of epoxide group also in the question. Whether the epoxide group is above the plane or below the plane. So the real question is about stereochemistry versus reaction here. The answer is A. Let us see how. The starting metal contains acidic carbon. You are using lithium HMDS. So the proton abstraction will be there. You can write from the inlet form, but this will be simple to understand. So I written as anion there. Next step you are using the epoxide. So epoxide can be opened from two places, 1 and 2. Epoxide is a strain system, so it should be open. The negative charge specifically attack the 2, not the 1. So Y means the steric effect there. So the less hindered side 2, which is second carbon, attacked by the negative charge. The attack is from the above. Y means because the molecule already having bulk isopropyl group, that's why attack is from the above. So the new carbon-carbon bond formation occur, which is above the plane. Then the next step you have ion and good leaving group tosylate. What really happened is intra-reaction happened. So O minus hit the carbon, TSO leaves there. So again you have epoxide formation. So you start with one epoxide and end with another epoxide there. But stereochemistry defined by the nature of attack and bulky steric group isopropyl. Here you have to learn two things. One is when attacking you have to always look for the bulky group because it dictates the stereochemistry there. Second thing is if you have good leaving group as well as strain in the system, always think of consecutive reactions. Then the question number 5. The starting metal is benzene attached with iodo and orthoamines, and you have the system of alkyne with trimethylsilyl and alcohol. Here you are using palladium reagent and you are using phosphate and quaternary salt and sodium carbonate. Here 4 products are given. The products are difficult to guess because the annihilation happened there. So the way or selectively the annihilation is occurred where the CH2OH group is in the real question, as well as you have to find SiMe3 is removed from the system or not. So here ring closure definitely occur because you have indole formation and one naming reaction is involved here. The answer is D. Let us see how. The reaction is organocatalytic reaction with phosphine and palladium. The synthesis is called Laroque indole synthesis. It's an important naming reaction. So don't confuse with Sona-Kazira coupling because since you see the triple bond and iodine you might guess it's a Sona-Kazira coupling, but it is not. It's a Laroque indole synthesis. It's just the addition of alkane to the system and the annihilation there. The first step is iodine removal and palladium integration there. So palladium integrated. Next step you have the addition of alkane. Here during the addition the bulky group go away from the benzene ring. So SiMe3 is the bulky one, it's go away. That's why SiMe3 away from the ring, CH2OH is near to the ring there. It's a coupling reaction. Mechanism is difficult to be described here. You have to study separately. So asymmetric alkane addition happened. The product is indole, which is D. Here you have to learn one very important thing, which is Loroch-indole synthesis, and the bulky group go away from the benzene ring is the selectivity here. That's all from this episode. I hope it was useful. Thanks for watching. If you have any suggestion, comment below. Stay tuned for next episode.